Okay, good morning, everyone. My name is David Simpson. My information is up on the screen there for you. And so this morning's webinar is DB2 SQL for the 21st century. So this is a presentation that I've done a couple of times now at different user groups and actually at iDoug as well. And it can either last a few, an hour, 2 hours, or all day. Done it all the different ways. So what I'm actually going to do with this is do a couple of the topics today, and then I've already scheduled a follow-up for next month in March, and you'll see a link to that a little bit later. So we're going to do this as many parts as we think are helpful, and I'd love to get your feedback on how helpful you thought this was, and maybe what other SQL topics you'd like to see. So my email address is on the board there. You can feel free to use that. You can also follow us on Twitter at Themis Training. And with that, I will talk a little bit about our sponsor for today. So this is the company I work for, Themis Education. We do training on a variety of topics in IT. You can see some of them there, but one of our primary focuses is DB2. And I think we have the most complete DB2 curriculum, everything from SQL application programming all the way up through DBA stuff and even system programming and installation. So you can check us out at themisinc.com. There's a link down at the bottom there. I'm going to say this a couple of times because I know people are still joining us. If you would like the slides for today's webinar, you can visit that link toward the bottom there, themisinc.com/webinars. Toward the top of the screen there will be a box for today's webinar, and it will have on there, it has there already a link to download the slides that you're looking at. So if you would like to take home the PDF for your review, you can have that there. And within a couple of days, hopefully, we'll have the replay of this webinar up. So if you enjoyed it so much that you want to share it with your friends, that will also be at the same link. So again, the slides are available. After every one of these, I get probably 10 questions about where can I find the slides for it. So I'll say it a couple of times here. You can get them at themisinc.com/webinars. So the kind of training we do on all of these topics, we actually have training 3 ways. We can come to you if you have a big group. We have a public schedule that runs at various locations throughout the USA mostly, but we also have distance learning, which is really the same as our public enrollment stuff, where an instructor shows up live. It's just done virtually, and that can be taken from anywhere in the world. It is a live instructor. It's not like you're playing a tape. So we would of course love to be considered for any of your organization's training needs, and what you're seeing today is actually a small piece of our DB2 Advanced SQL course that we teach for both LUW and ZOS. The majority of you that signed up today said you were ZOS people, but the SQL you're going to see today really works on both platforms, with one small exception that I'll try and remember to note a little bit later on. If you go to that webinars portion of our page, themisinc.com/webinars, you'll see, first of all, the download for the slides today, and you'll see replays of past webinars, which is pretty cool. You'll also see at the very top upcoming webinars that we have scheduled. So in March, we have 2 planned. One is one of our Oracle experts, John Mullins, is doing 20 essential Oracle SQL and PL SQL tuning tips. So for those of you who work on both DB2 and Oracle, or if you have Oracle friends in your organization, feel free to pass that one around. That is, again, another free webinar just like this one. And then also in March, we have part 2 of this presentation, which is already scheduled toward the end of March as well. Again, all the details, themisinc.com/webinars. You can download slides, view past webinars, sign up for future webinars. So please feel free to share this with anybody you find that might find it useful. All right, so a little bit about me. I will not read all of this to you. I've just been working with DB2 for a while, is pretty much what that says. Since about 1993. In the last 10 years or so, I've been doing a lot of speaking at conferences, user groups, and so on. And the last 8 years or so, I've been teaching these classes with Themis. So that's a little bit about me and where to find me. Again, my email address is there, dsimpson@themisinc.com. If you have questions, you can put them in the questions box, and we will try to get to some of those as we have time. Or you can send me email afterwards, and that is a great way to find me as well. So I will try and respond to any emails that get sent after the fact with answers, or at least hopefully sort of intelligent thoughts about your question, which is sometimes the best we can do. All right, so that is me. Also quick, the material you're about to see comes from our advanced SQL class. If you download the slides for the presentation, there are hyperlinks in there for the full description of that class, and we have a distance learning version of that coming up on March 14th. For those of you who may be interested in, like, seeing 3 days of this stuff. So there you go. All right, so the topic that I pulled out of the presentation that I can spend multiple hours talking about for today is table expressions. So we're talking about, the topic here is SQL for the 21st century. Are you writing code, SQL in particular, using the features that are available to you in recent releases of DB2, or are we still writing code the way it was done back in the 90s? So that's kind of where I'm looking. The feature that we're going to talk about today, the main one, came in version 8 of DB2. So that's actually a little while ago now. Although I've been working with DB2 since version 2 dot something. And so the stuff in version 8 is still relatively new to me, although it's been around for about 10 years now or so. Okay. The version 8 gave us, version 4 gave us the original kind of nested table expressions, we called them, and version 8 gave you common table expressions, which is where the focus of the presentation is going to be today, because those are the newer kinds, and the kinds that I find are not as widely understood, I guess, as the older kind. So we'll take a look at table expressions. They're really, really useful. When I teach the advanced SQL class, we spend about a half a day on these things, and I have people tell me that was kind of the most practical thing that they got out of advanced SQL class. So that's where I've chosen to start off with this series of webinars. So we'll talk about the old kind briefly, and then use that to leap into the new kind. Nested table expressions. This is where you take a select and you put it inside the from clause of another select. And this is really a great example of the brilliance of the people who invented SQL, whoever they were, right? It comes from set theory and math. But the fact that a select statement produces a table, and that the input to a select statement is also a table, or tables, is brilliant, right? Because it means that we can build the selects on other selects. The output of a select is also the input to a select. And that's really the basis for table expressions. So these are sometimes called inline views. That's what I heard them called when they were first introduced back in the 90s. And that's really a great description of them. They're a view that you're creating kind of in line of another select statement. Kind of, you can think about it as a virtual table created for just the duration of your query. Unlike views, they aren't documented anywhere except in your select statement. Basically a full select statement enclosed in parentheses. All right, so we're going to look at an example. I think most people are familiar with this kind of select statement. So here's the sample data we're going to be looking at. This is actually just pulled out of the good old IBM sample database. You know, they got fake employees, fake departments, those kind of things. So this is a sample employee table that we're going to be looking at for the first part of the presentation. And it's just people who work in our little fake company, the salaries they make. You can see that the salaries, you know, reflect probably the 1980s when this data was invented. So the president of our little company is the lady at the top there, Christine Haas. She makes $52,000 and some change, which I know is about exactly what the CEOs of all your companies make. Somebody mentioned to me that might actually not be annual. That could be like hourly or something. Anyway, so this is some of the sample data we're going to be looking at. You notice each employee is assigned to a department, right, or a place that they work within the organization, and we're going to be kind of rolling up data at that level with some table expressions. So here's an example of a nested table expression. And these things are really commonly used for aggregating or combining aggregate data and detail data. So what I'm trying to accomplish here, I think, is I want to get a list of employees out of my table. Looks like I want their employee number, last name, their salary, the department number they work in, but I would also like the average salary for that department, for all the people who work in that department. Well, I can easily write a query that will find the average salary for each department. And that's what we have in the red here in the middle. You could pull that right out of the parentheses and run it by itself. Select department number and average salary grouping by department number. So that'll give you that group by gives you one row for every unique occurrence of department. And then the averages are applied to the group, right? And we're then taking the results of that, because that produces a table, columns and rows, 2 columns, and in our case, I think 8 rows, and we're joining it back to our detail employee data. So nested table expressions are a great way to mix detail and summary data. You can do a lot of other things with them too, but this is one of the really primary uses that I find for nested table expressions, is to mix the detail and summary data. Okay, and when we do that, when we run this query, we get a result that looks something like this. All right, so you see we have 2 Christine Haas's in our little sample data. They are actually 2 separate rows in that table, employee number 10 and 11. They kind of look the same though. Right, and you see all of these first 4 employees work in department A00. They each have their own individual salary, but we're mixing that. This last column here came from that table expression. Right, so the average salary for department A00 is $45,312.50. And that is the same for all of those first 4 employees. In other words, that column, the value for that column came from the one row that came out of the table expression for that department. So I'm mixing here detail and summary data, which is a really, really great use for table expressions. And you can see that going all the way down. You know, department D11, the last one here, those last 9 rows, I think, all have the same average, right? They all work in the same department. So you can see an individual employee's salary and how it compares to the average for his or her department. Again, great use for table expressions. All right. If I go to the next example, though, did you know that you could also write this same query this way? Okay, so you can actually now, and this is the version 8 stuff, use a common table expression to do the same thing here. These things are actually a little bit more flexible, and we'll see a great example of that in just a moment. But rather than embedding or nesting the definition of the table expression in the from clause, here I'm kind of defining it outside of the query that references it. Now the stuff in the box here is all one SQL statement. Right, so it's, you know, if you were doing this in COBOL, right, be exec SQL at the top and exec down at the bottom. It's all one SQL. but it starts out with the word with, which, for people who haven't seen this before is a little bit annoying, I guess. We expect select statements to start with the word select. But really, before I start selecting things back to the final result set here, I'm defining a table expression. I'm defining a little table that I'm going to use called dept_av. Right here is where I name it. All right, so this dept_av is not actually reserved word or anything. That's just the name I'm giving for this table expression. And it is defined as select department number and average salary from the employee table grouping by department. That's the same thing I had in the table expression in the previous example. You can think of this again as, this little table is being built first, and then I'm going to query it so that when down in the main body of my select, I make a reference to dept_av, I'm referring to this thing that already exists. Now, physically, in the access path, that may or may not be true. In other words, DB2 might pre-materialize this thing, or it might try and merge these two queries together. Sometimes it can do that. But it's easy enough just functionally to think about it as the table in the red is being built first and then used or referenced down in the main query. The thing that I'm going to actually see come back is the results of this select that's in black, and we'll actually get the same answer as I got before. All right, so this is just another way to write the same thing. I'm pulling the table expression out of the from clause and building it ahead of time, ahead of actually executing this query. So this, you can see this works a little bit like a temporary table. It's not a temporary table in the sense that it dies as soon as my query finishes. So there's no taking this common table expression and passing it on to another separate select, at least not exactly. But it is just another way of writing the same thing. Now these two, the nested table expression versus the common table expression with the example I've listed will behave the same way, they'll perform the same way. It's all good. However, the nested table or the common table expression, this one actually is a little bit more flexible. And I think we'll see an example of the additional flexibility very shortly here. So just at an academic level, a common table expression is defined at the beginning of a query once, can be used in any from clause inside the query. That's kind of interesting. The example we've seen so far only had one from clause inside the query. We'll look at some examples that have more than one, though, where that'll really become important. Nested table expression can be placed inside a from clause, but if you're going to use it in more than one from clause, you got to redefine it, and we'll see that, I think, right now. So here's a sample problem that we're going to try and solve with table expressions. We want to return the department number and total payroll for the department that has the highest payroll. Payroll is defined as the sum of salaries and bonuses for that department. Okay, so this one always got me a little nervous when I saw questions like this being asked that we're trying to solve with SQL, especially before version 8, where we had common table expressions, because I see two levels of aggregation there. First, I have to find the sum of salaries and bonuses, right? That's one level of aggregation. Show me total pay for each department. And then I want to, of those, find the maximum. So sum and max are both column functions or aggregate functions, and I can only do one of those at a time. I can't find a max of sums very easily, right? First, I got to find the sums, then I'm going to take those and find the max. And so this is how I might have done it in the past. Solution number one, make friends with the DBA. Some of you are DBAs, right? Those of you who aren't, good to have a friend that's a DBA, and one of the friendly ones too, right? So get the DBA to create a view that does one of the levels of aggregation. So in this case, I've asked the DBA, please create me a view that does select department number and sum of salaries and bonuses, grouping by department number. What is that view going to look like? Well, it's going to have one row for every department and the total payroll for each department, right? So one level of aggregation, grouping and summing. Then in the second box, we go query the view and we say select the stuff from depth pay where the total, that total is the column that we manufactured here, right? Sum of salaries plus bonuses in the depth pay view, where the total is equal to select max department total from depth pay. Right. And this is actually fairly straightforward. Downside, you needed to make friends with the DBA, but another downside is that you see two references to depth pay here. I'm referencing the depth pay view in this from clause, and in my subquery down here, I'm referencing the depth pay view again. When you reference a view twice in a query, it's going to have to get built twice. And this one, I'm pretty sure it's going to have to be materialized because I did this thing called group by. So even though it looks kind of simple to write it in that second box, it's actually kind of complex for DB2 to handle. It's going to have to kind of build that view twice. Right? A view is not a real thing, right? Everybody familiar with that? A view is something that can actually get built at runtime. It doesn't, it doesn't persist. It's not like this data is being aggregated and then stuffed in a corner somewhere. DB2 manufactures it when it needs it. And so when I run this, I get the answer. My department D11 has a total payroll of $226,000 and some change, and that is the final answer. Right, that's the department with the highest payroll. Keep in mind, this actually could be more than one department. Right? I'm not necessarily looking for a single row answer here, because if two departments had the payroll, the same payroll, of 226,600, and that happened to be the highest number, this max function doesn't return two rows. It just returns the maximum value. But then that outer query could actually match multiple departments to that value, right? So if two departments had the same total pay and they were both the biggest number, then they would both get returned by this query. All right, so two downsides to this one: you got to make friends with the DBA. And DB2 is going to have to work pretty hard at building this view twice because you referenced it twice. If you look at solution number 2, is the next one. Solution 2 is use nested table expressions. This is exactly the same actually as solution 1. The difference being that everywhere I referenced the view called depth pay in solution 1, well, now since I haven't gotten the DBA to create that view, I have to build out the definition of depth pay. So the stuff in the parentheses here, right down here, this select sum grouping by, this select sum grouping by, I'm repeating twice, and that's really just the definition of the depth pay view that I used before. This is just kind of being explicit about what actually happened in the first example. So I could do this with nested table expression, but anytime you find yourself repeating a big chunk of code, you probably want to look for a way to do it only once. And that is really the extra flexibility that common table expressions give us. So solution number 3 here, use a common table expression. That thing was defined outside of the actual main body of the select. And one of the advantages of that is that it's available anywhere inside. This thing's going to get built once. And especially because the stuff going on in that table expression, group by, what do you think's going on every time you say the word group by? Or not every time, but a lot of times anyway. How does DB2 get all of the individual rows of the employee table together to do the grouping and rolling up? Well, it probably has to sort. Okay. Now, if you have the perfect index, it might not have to sort, but group by is very likely to cause a sort. And I'd really like to do that sorting only once instead of twice, particularly if this is the largest result set. So by pulling it into a common table expression, I can do it once and then use it twice. Right. So now down here, when I say select from depth pay where the department total is equal to the max from depth pay, this is almost like using the view. Right. But it's not actually building this thing twice now, it's building it once. You can think about this like a little table that's going to get built at the beginning and stuffed aside in memory and then queried multiple times. Right? So In this case, if you actually were to look at the explain, the access path would look a lot better. It probably is going to perform a lot better, and it certainly is easier to write than repeating, basically in the previous example, we're repeating all of this stuff every time we needed it. And we have a couple of examples in the workshops that we do in the Advanced SQL class where you actually need to repeat the same thing more than 2 times if you're going to use nested table expressions. So common table expressions give you some flexibility that you wouldn't otherwise have, and these expressions I think are some of the ones less frequently used and just kind of not quite as well understood, mostly because in DB2 ZOS anyway, they're fairly new. And when I said they're available in version 8, I am talking ZOS there. LUW folks, you had this a little bit longer, right? You had this before ZOS folks got it. So on mainframe DB2 anyway, I find this is not as well understood. So you want to have that in your tool bag, right, in your box of tricks. Whenever you need to do aggregation or mix aggregate data with detailed data, you can do it with table expressions, but common table expressions will often give you more flexibility than the nested table expressions that we tend to be more used to. Okay, so this example is stacking multiple common table expressions into a single query. So here I have 2 common table expressions. One's called X, the next one's called Y. It looks like, in this case, Y is not querying X, but you can actually, this is really useful if you've got kind of waterfall reporting requirements. In other words, common table expression number 1 can feed data to common table expression number 2, and then the outer query can join it all together. Here it looks like I'm summarizing employee data by department, and then in X, and then I'm summarizing project data by department in Y, and then I'm joining it all together. So it looks like for every department I want to see how many employees does it have and how many projects does it have. Right? And that would actually be kind of hard to do otherwise. So I've got 2 table expressions here, one looking at employees, one looking at projects, and then in my final query I join them together. Not shown here, but certainly possible is the second table expression, Y, could actually query X. Right, so you can have one feed another that way, and that's another way of adding some complexity. You see this a lot on LUW, actually, where there have been historically a lot of big data warehouses, these multiple common table expressions doing kind of complex reporting, where you need to summarize one thing and feed that into a kind of a super summary at the next level, and then at the bottom, kind of pull it all together. So that's multiple common table expressions. There's no real limit to the number of these. Well, I think in later releases of DB2, you can have something like references to 250 tables in a select. So that would be the only hard limit, is if the sum total of things you were accessing exceeded that limit. All right. Also, with these common table expressions, we can do recursive SQL, which is another thing that came to us for ZOS people in version 8. LUW people, you had it earlier. But recursive SQL in DB2, or the ANSI standard way to do recursive SQL, is built on common table expressions. If you go to Oracle, they have other ways of doing this and have also fairly recently adopted this way as well. But this is the I think standardized way to do it. So what we want to look at here, oops, and I'm sorry, I've mislabeled that last column here. Oh wait, that's the wrong even data. I apologize. I'm going to fix that in the slides. Let me actually go to the real data here so that you can see it. Okay, so we have projects in our project table, and every project has what's referred to as a major project. So in other words, projects are sub-projects of other projects. So I'm saying here project number AD3110 is really a sub-project of AD3100. And the question off here to the right, which is pointing at the wrong data, but the right question off the right. Let's say if I want to find all projects that are under project AD3100. So not just the ones that are directly report to it, but all the ones that are under it and all the ones that are under that. That is a recursive question, right? We've built a hierarchy into our data, and we have we're asking a recursive question of that data. Okay, so the way to do that prior to recursive SQL is something like this. Take the table and join it to itself, and that'll let you go one level deep. All right, so here we're saying find all the stuff that's directly under 3100 and the stuff that's under that. Right, if I want to go another level deep, then I would have to do something like join it to itself again, and at some point I'd better do left joins. Otherwise, I'm gonna start losing rows. So here you see I've got I think this is actually all of the projects underneath AD3100, but I've got it spread out across 3 columns, and your application program would have to sort it all out. I think the proper way to do this now is with recursive SQL. And recursive SQL would look something like this. Okay, so it actually has 3 pieces, and I think the best way to deal with this is to kind of look at it and stare at it for a while. Right? So it has actually 3 pieces to this recursive statement. It's going to have 3 parts to it. I've got an initial select here. I have a recursive select and then a final select. So the initial select is going to prime the pump, as it were. Show or put the first row into the common table expression. So in this example, we're going to put AD3100 into the table, into my common table expression. Then I'm going to say union all, and I'm going to add additional rows to the common table expression with this. Okay, with this second piece of the common table expression, and that is the recursive portion of the select. All right, so the recursive portion of the select is going to add additional rows, and what it's going to do is take this AD3100, that'll be in the progeno of this one, say take that major project from that first row that was already there and add new ones based on major project equal P note. Well, what I'm joining here, project or proj table, that's my base table, to the common table expression called projects. Well, what is projects? Well, it's itself, right? So I'm joining new rows in based on the rows that are already there. And the way recursive SQL works is that this piece of the select will continue to execute until there's no more data. All right, so the priming select there will put in project AD3100, and then the first iteration of the second one will say, hey, what are all the projects whose major project is AD3100? And then it'll execute again. What are the projects that are children of those? And what are the projects that are children of those? So every new row that gets added will trigger that recursive portion of the select to run again. You're kind of looping there without being explicit about it. And then the final select just says, show me what's there. Now, some of you are probably nervous already, I hope, right? Because that recursive portion, because it's looping, could go a little bit haywire on you. It could go haywire on you if you code it wrong, but it could also, your data could actually lead you into a loop. So if I switch back to my data for a second here, what if AD3100's major project was AD3110? Right? So these two then would both be children of the other, and we'd be in an infinite loop. Right? So we have to be a little bit careful with this. This can actually lead you into infinite loops. Other platforms have fairly easy ways of avoiding that loop. With DB2, you actually kind of have to code it yourself. Now here, this is the one case that I mentioned earlier where DB2 LUW and DB2 ZOS support just slightly differently. I've written this join as a SQL 92 syntax with the join on. In DB2 ZOS, you can write this either way, meaning you could use the old or the new join syntax, whether you use the word join or just commas there. In DB2 LUW, and I'm not real sure for the reason of this, but you have to use the old syntax. So actually, as I show it here, this example only works on ZOS. You would have to slightly change that recursive select to use the older join syntax. In other words, you would, instead of the word join here, you would have a comma. Instead of the word on here, you would have a where, right? But other than that, it would be identical. Okay, DB2 ZOS, again, supports it either way. LUW only likes the older join syntax, at least as of 10.5, which is where I tested it yesterday. And I actually tested it, again, sort of accidentally by cutting and pasting this exact sample into my LUW database, and it complained at me. Now, what happens if we get a loop? Well, you actually get an SQL code from this called +347, which I think is kind of funny. If you look at up +347 SQL code, it'll say, you coded a recursive SQL statement that might contain an infinite loop. It's a warning. What I think is kind of funny is, often anyway, if you actually code an infinite loop, you don't get the +347 because it's too late, right? You're already looping. You just go away and never come back, or not in a reasonable amount of time anyway. So yeah, that's an interesting SQL code. The result here is, all of the rows that are dependent in some way on 803100. We're actually going to add this last column in the last example. So the last example here is adding this leveling technique. And this is number one, so I can see how far from the top am I. But number two, it also allows me to cut off processing if I ever reach a certain number of levels. So I'm adding another column here to the result set called level, I'm just calling it LVL. When I put the priming select in, I'm adding just the number 1. And in the recursive select, I'm adding 1 to that. Right? So it tells me how far from the top am I. Right? And if I go back to the results here, you can see, these rows are 5 levels from the top. Right? These guys are all children of MA 2110, which is a child of MA 2100, which is a child of 803110, which is a child of 803100. That's 5 levels. Right? So that level tells me how far I am from the top, but it also gives me the option here of cutting it off. So in my recursive select, I can say, hey, if the level ever gets to be bigger than 100, let's stop. And you got to pick a number there that's reasonable for the data that you're working with. Okay. So I'm kind of manufacturing a column there that represents how far from the top I am. And if you do this technique, DB2 actually detects it, and you don't get that +347 warning. It realizes that you have mitigated against a pure infinite loop. Now, 100 levels is not necessarily 100 rows, right? It means 100 levels from the top. And you can see in my example here, like level 5 had at least 3 values, right? So every level can have multiple rows. You could still get a lot of data, and the data might not make any sense if it is actually looping, but we won't actually run away and never come back. Okay. So recursive SQL is one of the neat benefits of common table expressions. In DB2, there's no other easy way to support recursive SQL. If you go to other platforms, they have kind of proprietary syntax for doing this in addition to this technique. But this is the way, the kind of standard way to do it that's supported now, I think, on all platforms, and certainly the way we should be coding it on DB2 ZOS. Right. So if you want to come back for more of this, part 2 of the webinar we're going to have in March, I think March 23rd-ish. It'll be on the website, themisinc.com/webinars. You can sign up there. The topics that I'm thinking of leading with for that one are some advanced aggregation ranking and row numbering. These things came in version 10 and 11, and are real helpful for kind of complex reporting and aggregation requirements. And based on your feedback, we may add additional topics as well. I don't know how many parts will be in this series, but we'll keep doing it as long as people keep signing up for it. So feel free to come back for that. As I mentioned at the beginning, we also have an Oracle tuning tips for PL SQL in March. You can sign up for that at the website as well, or share any of these with any friends that you may have that may be interested in these topics. Again, themisinc.com/webinars is the place to go. You can also get the slides from this presentation, and replays of this presentation and others are going to be available there. I noticed that we hit the max here on the number of people that could attend. So if any of your friends are grumpy that it told them that they couldn't get in because they came in late, feel free to direct them also to this website, and I'll try and send an email out that's a reminder when that's posted. So the replay of this will be available themisinc.com/webinars within the next couple of days. So thanks for attending. If you have any questions, please use my email address that was at the beginning. I'll put that back up, I hope. dsimpson@themisinc.com. Feel free to send questions that way, and I would love to hear requests also for other kind of advanced SQL or new SQL kind of topics that we can cover in future webinars. So thanks for attending today. Have a great rest of your day, and we'll see you back next month, hopefully for the sequel.